Okay, let's see what we got so far. So let's start with synthetic division. So the trick with synthetic division is you put in the coefficients from up here. So if we're taking that function with coefficients 2, 13, 19, and 20, to divide by x plus 5 for part A, we don't put 5 out here, we put negative 5. The thing we divide by is what would make this, if it were a factor, equal to 0. So we're going to bring down the 2. We're going to multiply, add, multiply, add, multiply, and add. And we get 0. So if I look down to this question down here, if I look at my function, can I name a 0 of the function? Yes. Since f of negative 5 equals 0, 5 is a 0 of f of x. And if 5 is a 0, I could also say, negative 5 is a 0 of the function. Because when I put negative 5 in, I get 0. And if negative 5 is a 0, that means x plus 5, the thing I divided by, is a factor of f of x. So basically what that means is you could factor this to x plus 5, and then the other factor is right here, what's left. The 4 is going to be your 0 degree term. The 3 is going to be your degree 1 term. And the 2 is going to be your degree 2 term. So if you check and use the multiplication for that and distribute, so doing target 11 and multiply x plus 5 times 2x squared plus 3x plus 4, you will get the 2x cubed plus 13x squared plus 19x plus 20. So x plus 5 is a factor of it. And maybe this could be factored. I don't think it can, but maybe it could. Now, if I wanted to check part B to see if x minus 2 is a factor, I'm going to do the same thing, but what am I going to put out here? 2, positive 2, because positive 2 would make this 0. Bring down, multiply, add, multiply, add, multiply, and add. So what that means is if I divide 2x cubed plus 13x squared plus 19x plus 20 by x minus 2, I'll get 2x squared plus 17x plus 53, which is what I got right here, plus a remainder of 126 over x minus 2. Sorry if that's hard to see. So this last part here is my remainder. I get this plus the extra 126 over my divisor, x minus 2. So that means negative 2 is not, positive 2 is not a 0, and x minus 2 is not a factor, because there is a remainder. And that's how this all ties together. Yep?
Okay, so like the 2x squared plus 47, oh wait, no, what's the 7? Wait.
2x squared plus 17x.
Yeah, so like that whole thing. That's what you get if you did long division?
Yeah, and I was actually just going to do that. So let's let's do part B with long division just to kind of see the parallel there. It's considerably more work, but we do need to learn long division because not all problems can be done with long division. But I'm going to divide 2x cubed divided by x is 2x squared. 2x cubed divided by x, I subtract the exponents, so I get 2x squared. That divide x cancels one of the x's in the x cubed. Then I multiply that to my divisor. 2x squared times x is 2x cubed, same thing as up top. 2x squared times negative 2 is negative 4x squared. Then I'm going to subtract that from the top polynomial. So the 2x cubed minus 2x cubed is 0. That should always cancel. 13x squared, distribute this minus. So it's 13x squared minus a negative, which becomes plus a positive 4. So that's 17x squared. Bring down the 19x. Now I'm going to divide again. 17x squared divided by x is a 17x. I put a plus sign in there because our answer is a polynomial, so we need plus or minus signs to separate those. I multiply that to this whole thing. 17x times x is 17x squared. 17x times negative 2 is negative 34x. And then I subtract that from the polynomial above it. 17 minus 17 is 0. 19 minus a negative 34. So if I distribute that negative, it becomes plus a positive 34. So that's 53x. Then I bring down the next term, which is the 20. I divide again. 53x divided by x is 53. I multiply, I get 53x. And 53 times negative 2 is negative 106. And then I subtract. 53 minus 53 is 0. 20, this is the thing everyone messes up. Distribute that negative. So it's 20 minus a negative 106, which is 126. So look at what my answer is. 2x squared plus 17x plus 53 plus a remainder of 126. And I write the remainder over the divisor, x minus 2. Now let's go back and look at the synthetic again and how much easier it was, but we're still going to get, in our synthetic, we got the 2, 17, 53, and 126. Oh, right here. So clearly, synthetic division is much easier, right? However, if we have a problem where the divisor is not of that form, like this, synthetic division doesn't work that way. This one can actually be done synthetically, but there's an extra kind of thing to adjust. So I'm just going to say, if it's not in the form x plus a number or x minus a number, use long division. And ones that are like, well, that one as well. But if, I don't even know if I have any here. I'll have some next week. But let's say I had like x squared minus 5 out here. You couldn't use synthetic division that way either. It has to be x plus a number, x minus a number. Now, for this one, I would say use synthetic division, or excuse me, use long division. And then if you do long division and you get an answer, remember you can always check by multiplying. You check division by multiplying. For example, is 36 divided by 4 equal to 8? Well, let's check by multiplying. Is 36 equal to 8 times 4? No. I can multiply these to check that. I'm basically just solving for this, multiplying both sides by 4. So here, if 28x squared minus 23x minus 15 divided by this, does that equal that? Well, I can check by multiplying my answer by the divisor. So I would take 7x plus 3 and I would multiply by my answer, and if it's correct, I should get 28x squared minus 23x minus 15. And you could use a box method to multiply, but I'm just going to use the distributive property. So distribute the whole thing. That makes it easier. So I'm going to distribute the 7x plus 3 to the 4x. I'm going to distribute the 7x plus 3 to the negative 5. And the reason I'm distributing the whole 7x plus 3 is because of the remainder. When I distribute that to 5 over 7x plus 3, this one works out real nice because I have a 7x plus 3 divided by a 7x plus 3. So that part just becomes 5. That's your remainder, plus 5. So now these two, I get distributing. Now again, I get negative 35x and negative 15. And distributing here, I get 28x squared plus 12x. So now I combine the like terms. I have 28x squared, looking good. 12x and negative 35x is negative 23x, looking good. Negative 15 plus 5 is negative 10. Doesn't look good. So is this correct? No. I should get exactly this. All right, that's enough talking for now. Why don't you guys get out your Chromebooks, practice some Math Excel, ask for help. I know this is probably just going to take some time to ask. And if you're behind on any of the basic tests, feel free to use this time for those. Just let me know which ones you're working on or when you get them done so I can update the grades.
Why is that so good?